Jai Hind everyone. Today we are going to study quadratic equations. Before we move on to quadratic equations, let us see what is a quadratic equation. As you can see on the board, in mathematics, a quadratic equation is a polynomial equation of the second degree. Remember, it is the second degree. This means out of all the terms of the polynomial and the subsequent equation, there is definitely going to be a term with degree 2, a term with degree 1 and a constant. Remember, degree 2, as you can see, ax square is compulsory. Rest, even if they are not there, we can still manage. But what is compulsory is the x square term or the square term. Where, let's continue there, where x represents a variable or an unknown, and a, b, c are constants with a not equal to 0. See, this term a not equal to 0 just reiterates what I just mentioned. Because if a is equal to 0, the x square term goes off and we are left with bx plus c equal to 0, which represents a linear equation. The constants a, b and c are called respectively the quadratic coefficient, the linear coefficient and the constant term or the free term. Now remember, whatever is the degree, the same name falls for the coefficient. That is, if the term is x square, that is a quadratic term, the coefficient is called the quadratic coefficient. For the linear term, the term which is linear, the coefficient is called the linear coefficient, and the constant is also called the free term because it's obviously, it's free of any variable. Then let's move on to quadratic and roots. Now children, we've already studied this in our previous chapters, that whatever is the degree of the equation, we have those many number of terms, at least those many. That is, for a quadratic polynomial of degree 2, which is equal to y equal to ax square plus bx plus c, and if you put an equal to 0 on the other side, then you get ax square plus bx plus c equal to 0. It is a quadratic equation. Now just see, it's always mentioned a not equal to 0. Remember? What will happen if a is equal to 0? Yes, it will become a linear term. Now here is an example. 5x square minus 3x plus 3 equal to 0. And can you see the x square term highlighted over there? This is the thing that makes it a quadratic. The name quadratic comes from quad, meaning square, because the variable gets squared like x square. It is also called an equation of degree 2 because the 2 on the x. I think all this has been revised, has been taken up in earlier classes also, and this just forms the firework for the next thing. Yes, let's come to the roots. Now, what are the roots of a polynomial? What are the zeros of a polynomial? Does something come to your mind? Yes, let's see. A real number alpha is called a root of the quadratic equation ax square plus bx plus c equal to 0 if a alpha square plus b alpha plus c equal to 0 holds true. That is, whatever is x, if you put the value of x as alpha, the equation turns out to be 0. In simpler terms, basically the value of x for which the equation becomes 0 is called the root of the equation, or in simple general terms it's called the value of x or solution of the equation. If alpha is a root of the given equation, then we can say that, look at the first point, I think I just spoke that, x equal to alpha satisfies the equation ax square plus bx plus c equal to 0, or x equal to alpha is the solution of the given equation. Now, root of a quadratic equation, which is alpha, and is also called, this alpha basically is also called 0 of a polynomial. See, these two words are generally used interchangeably. The 0 of an polynomial, the root of an equation. See, there are two things. One is polynomial, one is an equation. What's the difference between a quadratic polynomial and a quadratic equation? The quadratic polynomial will be ax square plus bx plus c, as you can see. Simpler. Simpler terms, ax square plus bx plus c. Do not put equal to 0, and that's a polynomial. The moment we equate it to something, it becomes an equation. Just pay a bit of attention on the word equate. We equate it with something. Here we've done equal to 0. The word equate, the word equation. That is the difference between a polynomial and an equation. Whatever is the value of x for a given polynomial, that's called 0 of a polynomial. And whatever is the value of x that satisfies the equation is called the root of an equation. The difference, the thin line of difference between a polynomial and an equation, the same line holds for the difference between the terms 0 and a root. That's the only difference. And because we have a quadratic equation, we're going to have two roots of this quadratic equation. Or, let's go back, if it's a quadratic polynomial, we're going to have two zeros of a quadratic polynomial. I hope everybody is clear with this concept. Let's move on to more examples of quadratic equations. See, all the time the equations, they do not look as rosy, as simple. They can be twisted. You will have to find out, you'll have to use a bit of arithmetic or algebra to find out whether the given polynomial, whether the given equation is actually quadratic. Just see the first point. 2x squared plus 5x plus 3 is equal to 0. Yes, it is a quadratic equation. A, because it has an equal to sign, obviously it's an equation, and y quadratic because there's a quadratic term, which is the x square. Look at the coefficient of x squared, 2, coefficient of x plus 5, coefficient of, the constant term is 3, wherein a is equal to 2, b is equal to 5, c is equal to 3. Compare this with the general term or the standardized form. Look at this, ax squared plus bx plus c. A is associated with x square, b with x, c is the constant. Move on to the next example and see. A is 2. In the first example, look at this. A is 2, b is 5, c is 3. Now, had it been minus 5, then b would have taken the value as minus 5. That is, we will always take the signs also. Look at the next one. It says x squared minus 3x is equal to 0. Now here we cannot see any constant. That means c is 0. And here x squared, a is 1. Yes. What is the value of b? Minus 3. Let's read the text. This one is a little more tricky. Is it really tricky? Let's see. Where is a? Yes. In fact, a is 1, as we don't usually write 1x squared. We simply write x squared. So, as I say, 1 is omnipresent. So, x square would mean 1x square and a is 1. B is minus 3. And where is c? Well, c is equal to 0, so it is not shown. No need to write 0. Then, 5x minus 3 is equal to 0. Oops, this one is not a quadratic equation. Yes, because it is missing in x square. In other words, a is equal to 0. Let's go back to the previous slides here and see. A real number alpha, let's read the first sentence. A real number alpha is called a root of the quadratic equation, such and such. And look at the last word mentioned below the book, a not equal to 0. The moment a turns out to be 0, it becomes a linear equation like in the third example here. Hidden quadratic equations. Now what are hidden quadratic equations? Hidden quadratic equations basically are the equations which you people are scared of. Yes, you people are scared of anything that turns convoluted, and let us see how to solve this. So far we have seen the standard form of a quadratic equation, which is ax squared plus bx plus c equal to 0. But sometimes a quadratic equation doesn't look like that. Here are some examples of different form. Look at the first one. In this guise, x squared is 3x minus 1. Now you would say, ma'am, x squared is 3x minus 1. Where is the standard form? Where is the equation? The only solution is keep everything to the left and put only an equal to 0 on to the right. That is, move all the terms to left hand side, and in standard form it becomes x squared minus 3x plus 1 equal to 0. Does it look like a quadratic now? Yes. Wherein a is 1, b minus 3 and c is 1. Then move on to the next. Oh, now we have a different variable. Twice w squared minus 2 times w is equal to 5. Now what do we do with this? Now there are two ways to do it, children. What you can do is you can actually move this 2 onto the right side, so that it becomes w square minus 2w is equal to 5 by 2. Or, yes, multiply by 2. 2w square minus 4w equal to 5. Look at the third column, the third cell in the third column, second cell in the third column, 2w square minus 4w minus 5 equal to 0, wherein a is 2, b is minus 4, c is minus 5. Now here also we've shifted 5 from the right hand side to the left hand side so that it becomes a standardized form. Similarly, the next one is z minus 1 equal to 3. Now what do we do? Yes. In the previous one we multiplied by 2, which was a constant, a number. Now we're going to multiply with the variable. See, the method is as simple as that. Whatever comes to your mind, whatever simplification comes to your mind, you please do that. And if it's a quadratic equation, it will come out on its own. Z minus 1 equal to 3. Expand and move 3 to the left, you get z square minus z minus 3 equal to 0. And as such here, yes, a is 1, b is minus 1, c is minus 3. Now look at the third one. 5 plus 1 by x minus 1 by x square equal to 0. Now children, here I would like to take a bit of your time. Look at the equation. 5 plus 1 by x minus 1 upon x square equal to 0. Now this time for a little tip. As a teacher, as a guide, I would always suggest that whenever you are solving any equation, never ever should you leave the variable in the denominator. Always take LCM, cross multiply, do whatever is possible in that question, and always make sure that the variable is always in the numerator. This is going to help you by leaps and bounds. See, the trick here is multiply by x square. Multiply by x square would just mean take the LCM in simpler terms. And when you take the LCM and cross multiply, you get 5x squared plus x minus 1 equal to 0. And it looks like a regular quadratic equation to us. Now there comes the question how to solve such equations. See, basically there are 3 ways to solve. You can always solve a quadratic equation by splitting the middle term factorization. If you look at the previous examples, you will see that all the quadratic equations are 3-term equations here, or maximum 2-termed equations here. What you can do is you can try factorizing them by splitting the middle term, or by taking common, by using an identity, whatever suits. Then the next one is a foolproof method, which is using the quadratic formula. The third one will be completing the square. That becomes a little tricky, but believe me, if you're able to understand that, it becomes the shortest method to solve. So let's go on to the quadratic formula. This is a very interesting formula. Looks a little long, but then the moment you're able to practice it, you'll remember it for life. X is equal to minus b plus minus root b square minus 4ac upon 2a. Looks quite complicated. We'll try and simplify that. See, what is b here? B is, yes, your regular a, b, c. First thing first, you should always have the quadratic equation in standard form, which is ax square plus bx plus c equal to 0. Then jot down the values of a, b and c and put it in the formula. Now, one thing here, can you see in the formula, it is x square, x is equal to minus b plus minus. Now, when they say plus minus, that means here 2 values of x are hidden. First value of x will be minus b plus root b square minus 4ac upon 2a, and the other value of x is going to be minus b minus root b square minus 4ac upon 2a. That means first you take plus, that becomes the first value of x, and then you take minus, that becomes the second value of x. Here they are saying let the 2 roots be alpha and beta, and this way. You can have first root, second root, you can except x, a, b and c, you can use any other alphabet, any other language alphabet, anything. But alpha and beta are the general notation, mathematical notation that we use by convention. Now, the expression b square minus 4ac itself is called by the name discriminant. It is called a discriminant because it can discriminate between the possible types of answers. It can be denoted by d. Now, what is so special about it? You know, children, this value discriminant, b square minus 4ac, just this value, b square minus 4ac, This can actually tell you what kind of solution the given quadratic equation is going to have even before solving it. Yes, even before solving, it will tell you what kind of solutions it will have. See, we're going to have two solutions for x. Either they are both same or they are different, right? So, how do we get to know? When b square minus 4ac, that is d, is positive, we will definitely get two real solutions. Two solutions. In case it is 0, then you get both answers as same. And when it is negative, you get two complex solutions. That is, let's read the table. Value of d. In case d is positive, you get real and unequal roots. In case d is equal to 0, you get real and equal roots. Both roots are equal to minus b by 2a. That is, it will turn out to be a whole square identity. And if d is less than 0, you will have to write no real roots, and the roots will be complex. Yes, we can find out the roots, but then that becomes a little out of the reach of our syllabus that we're going to study in the next classes. So we would stop there and say no real roots exist. Now remember, there's one common mistake that students do. They say no roots exist because we don't know, because they're complex. So please do not write no roots exist. Let's write the complete sentence. No real roots exist. How do we use the quadratic formula? Just see, look at this example. Solve 5x squared plus 6x plus 1. Now what you're going to do here is look at the coefficients. A is 5, B 6, C 1, and it is already in standard form. Let's put these values of A, B and C in the quadratic formula. If you see, it's going to be minus B plus minus root B square minus 4AC upon 2A. What is B? 6. So minus 6. Plus minus b square minus 4ac. b square, 6 square, minus 4 times a. What is a? 5. What is c? 1. So 4 into 5 into 1 upon 2a, which is 2 into 5. Now once we solve, we get x is equal to minus 6 plus minus. 6 square is 30. 4 into 5 is 20 upon 10. 36 minus 20 is 16. And 16, the square root of 16 is going to be? No, it's not 4. It is plus minus 4. Yes. So children, you are in class 10. You should always remember that whenever you are taking a square root, you should always see whether plus minus values also hold. So one time we'll take plus 4, one time we'll take minus 4. Putting in the values and solving, you get minus 0.2 or minus 1. See, the answer is x is equal to minus 0.2 or x equal to minus 1. Let us check whether these are true, whether the calculation is right. And for the check, what have they done? What have we done? We've simply put in the values of x. First as minus 0.2, then as minus 1. And as you can see, this is simply verified and you confirmed that the values are minus 0.2 and minus 1. In examination or in any other things, children, these checks or these verifications are for your own self-assessment, but you will have to mention these only when they are asked. Now, factoring quadratics. Factoring quadratics would mean trying to factorize. If there are two terms, we simply use any square thing or common or anything, but when there are three terms, you can use splitting the middle term method. Look at the example. The factors of x square plus 3x minus 4 are x plus 4 and x minus 1. This is splitting the middle term. Let me just quickly have a rehash of splitting the middle term. What is the value of a there? 1. The constant is minus 4. You multiply 1 and minus 4 and you get minus 4. Now look at the factors of 4. 1, 2 and 4. We need to look out for those two factors of 4 whose difference is plus 3. Why difference? Because the product was minus 4. So the difference is plus 3. That is going to be 4 and 1. 4 and minus 1. When you put those values there, split 3x as 4x minus x. And you factorize, take common and factorize, and you get x plus 4 and x minus 1. If these are the factors, then what will be the value of x? Yes, x plus 4 equal to 0, and you get x equal to minus 4, and x equal to minus, x minus 1 equal to 0, and you get x equal to 1. Let us see, well, let us multiply them to see x plus 4 into x minus 1. On multiplication, you get, yes, x square plus 3x minus 4. See, multiplying x plus 4 and x minus 1 together is called expanding. In fact, expanding and factoring are the opposites. You've got a big polynomial, you try to find out with which two numbers were multiplied to get the answer, that's called making factors. And when you actually multiply, it's called expanding. Examples of factors. To solve by factoring, set the equation equal to 0. And what about factors? The factors will be linear expressions. Set each linear factor equal to 0. Solve both linear equations. See, x squared plus 3x plus 0. Take out x as common. So you get x plus 3 equal to 0. Now, if it is equal to 0, if two terms, the product of two terms is 0, that means either the first one is 0 or the second one is 0. Here, x times x plus 3 is 0, so that means either x is 0 or x plus 3 is 0. So you get x equal to 0, and x plus 3 equal to 0 gives you x equal to minus 3. Children, remember, in the previous slide, we did an example of a quadratic which had 3 terms, and here we've taken an example of a quadratic that has 2 terms. The second one was pretty simple for us to solve. We simply took out common and solved. The previous one used splitting the middle term. Let's move on to the much dreaded topic, which is completing the square. Solving general quadratic equations by completing the squares. Now, this method of completing the square is the one wherein we try converting the quadratic equation into a whole square and then try to solve. There are many tricks which many teachers or many students use, and as I say, each one to its own. The trick that you find easy should be followed. I'll just discuss one particular trick wherein we can use that idea to solve a quadratic equation, find where it is equal to 0. But a general quadratic equation can have a coefficient of a in front of x square, that is ax square plus bx plus c equal to 0. But that is easy to deal with. Just divide the whole equation by a first and then carry on. Now, many teachers, they would tell you that you can always factorize, or you can complete the square with ax square also. I would suggest that divide the entire equation by a first, so that at least the coefficient of x square is 1, and it's always easy for us to deal with it. Now look at the steps. Now we can solve quadratic equations in 5 simple steps. Step 1, divide all the terms by a, that is the coefficient of x square. We've done that. Then move the number term, that is the constant term c by a, to the right side. Complete the square on the left side of the equation and balance this by adding the same value onto the right side. The LHS becomes a whole square, equate it to the right side, take square root both sides and solve. Let's take an example. Solve x square plus 4x plus 1 equal to 0. Now if you can see, it is quite tricky for me to solve it by factorization. I'll have to look out for those factors of 1 whose sum is 4. And that's quite difficult, right? So let us see, step 1 can be skipped in this example since the coefficient of x square is 1. Simple enough for us. Move the number term to the right hand side of the equation, that is x square plus 4x is equal to minus 1. Now how do we perform step 3? Step 3, just see x square plus 4x. These are the first two terms, the x square term and the middle term of x plus something whole square. Just break this 4x into 2 into x. That is, it looks like 2ax. That is a, or the second term is 2. So it looks like the whole square of x plus 2. Now, what is missing here? Yes, 2 square. So what we're going to do? We're going to add up 2 square onto the left side, and same thing will be added onto the right side to maintain the balance. That is, you get x square plus 4x plus 4 is equal to minus 1 plus 4. Now the left hand side, just by adding 4 onto the left hand side, it becomes x plus 2 whole square, which is equal to 3. Take the square root on both sides and you get x plus 2 is plus minus 2, 3. And you can always solve. Now here I have done it for you, that is, I have solved root 3 equal to plus minus 1.73 up to 2 decimals. You can actually leave it like that. You can have the answer as x is plus root 3 minus 2 or minus root 3 minus 2. You can always leave it. Preferably you should use the value of root 3 only when it is specified. So children, that was the third method, and let's quickly have this chapter as a rehash. Quadratic equation ax square plus bx plus c, you can solve it by factorizing, formula, completing the square, and yes, drawing the graph. Now, drawing the graph would be making a parabola, and this particular technique was taken up in chapter 2, which was polynomials. Let us see factorizing. Look at the topmost block. It says it's easy. X squared plus 7x plus 12 equal to 0. You can actually use brackets and factorize. And for more difficult things, you can always use splitting the middle term. Then completing the square on the left side, what you do is x squared plus 4x equal to 3, and you add up and the same number on both sides, and then you make the whole square, complete the square and take the square root. Look at the formula on the extreme right, the second block on the right, x is equal to minus b plus minus whole square root b square minus 4ac upon 2a. Then the bottommost difference of two squares, this one is pretty simple, x squared minus 16, just an example. This will be x minus 4 and x plus 4. Put both these equal to 0 and you get x equal to 4 and minus 4. Or in the previous example that we did, it was x squared plus 3x. That's pretty simple for us to solve. Using the graph, yes, we've done that in polynomials chapter. For a quadratic polynomial, the graph is called a parabola. It's generally a U-shaped curve, and the points where the graph intersects the x-axis, they are the zeros of the polynomial. So children, this was the chapter in a quick recap. Hope you liked it. See you next time. Thank you.